Ladies and gentlemen, this is Pre-Calc Lesson 72. The title of today's lesson, we will have one side plus two other parts and law of sines. Today we will be mostly talking about triangles. So let's talk about triangles. Triangles have 6 distinct parts that we are going to talk about. They have 3 sides and 3 angles. This is kind of the duh statement of today. That's something we already know. The cool thing with that, though, is we can solve a triangle if one side and 2 other parts are known. Okay? So, if we know one side and 2 other parts could be another angle, another side, right? Those could be 2 other parts. We also know if we have triangles that don't have right angles, we call them oblique. So triangles without a right angle are oblique, not the obliques on your sides, but the oblique on a triangle. And this information is what we will use to figure out our law of sines. Our law of sines is a fantastic thing because it helps us be able to solve triangles. We have lots of different ways to solve triangles. Pythagorean theorem, similar triangles. These are all different ways that we have used. This is another. Now, important notation that we have, we will use capital letters for angles and lowercase letters for our sides. All that this means, the key thing in this, very, very important, is you label, for the love, label your triangles. Okay? So, what that looks like, if I have this triangle, I'm going to label this side A, this side B, this side C, lowercase letters for sides, and I'm going to have the opposite angle be the same letter but capitalized. Okay, so angle and their sides, their opposite side, are a pair. So the angle and the opposite side are a pair, meaning this and this angle, this opposite side, they are a pair. Which means we can set up our law of sines. This is the big law of sines. We can say that A over the sine of capital A equals B over the sine of capital B, which also equals C over the sine of capital C. Pretty nifty. We will only use 2 fractions at a time. We're not going to use all 3, you can only use 2. Okay? But if this equals this and this equals this, we can also say that A and C are a pair. Right? A over sine of A can equal C over sine of C, or B over sine of B can equal C over sine of C, or B over sine of B can equal A over sine of A. It doesn't matter which direction that you do it. Okay? So, once we have this right here, as I said, this is the law of sines. If you want to highlight it, underline it, circle it, put a sticker next to it, that is your law of sines. And let's do an example. So this is example 72-1, which is on page 451 in my book. Okay, and we are going to solve this triangle for its unknown parts. We have 7, 10, X. This is A, B, and 23. Be careful, sometimes my B's look like 13. Know that it's a B, not a 13. Okay, so the first thing I'm going to do is I'm going to write the pair that I know. I have this side and this angle, so I can say 7 over sine of 23. Those are the two that I have both pairs of. Okay. And I can use that to find one of my other missing side or angles. I don't want to use B and X because they're both unknown. But I can use A and 10, so I can then say it equals 10 over the sine of A. I can cross multiply, so 7 times the sine of A equals 10 sine of 23. So I divide both sides by 7. The sine of A is now 10 sine of 23 over 7. And I can then use a calculator. The sine of A equals, I can plug in this whole ginormous thing into my calculator, and it gives me 0.5582. Okay, now we have to go back and remember sine, we have all studs. Take calculus. Sine is positive in the first quadrant and the second quadrant. This is a positive term, which means I can have this angle here or this angle here. Okay? Now, to solve for A is the inverse sine of 0.5582, which gives me that A is approximately 33.93 degrees. That is one of my answers, okay, which would be this angle here. I can find the other angle over there by doing 180 minus 33.93, which gives me 146.07. That's my other A. But, okay, I have to be able to figure out which one is my possible angle. It is not possible for me to have 146 because angle A up here is an acute angle, meaning it is less than 90. And so I cannot have something that is greater than 90. That wouldn't work. So make sure you're paying attention to that ambiguous case. Now, if we know angle A and we know 23, we can solve for angle B by saying it's 180 minus angle A minus 23, which gives me that B is 123.07 degrees. And I can solve for X because I can use my law of sines and say again 7 over 7 over sine of 23. That's why we take notes in pencil, but I don't because you wouldn't be able to read it, equals X over the sine of 123.07, right? 7 is to 23 as X is to B. I cross multiply, so I have X times the sine of 23 equals 7 times the sine of 123.07. Divide both sides by the sine of 23. So I get X is 7 sine 123.07 over the sine of 23, which this lovely fact I can plug into my calculator, and it is approximately 15.01. Not degrees, because it's a side. Notice when we're solving for a side, there's only one answer we get. That will always be the case. There's no ambiguous answer when we are solving for a side. There's only an ambiguous answer when we are solving for an angle. Okay, If you need, pause the video so that you are able to look at this more closely, but I am going to move on and do another example. Example 72.2 on page 452. Okay, this is the triangle that I have. With all of these examples, I want to see the triangle in your notes. Okay, very similar to our last one, just have a slightly different triangle. Okay, see if you can find the similarities and figure out what we're going to do differently. Okay, so again, law of sines, I will have 7 over the sine of 23. And again, I'm going to have 10 over the sine of A. Well, if you notice in our notes, we already did this. I am going to show the work again of cross multiplication just for good measure. So we will have 7 sine of A equals 10 sine of 23. Divide both sides by 7. So then I will do A, right, is going to be the inverse sine of 10 sine of 23 over 7, which we already found that this equals 0.5582, or you could plug it into your calculator as this whole giant thing. But I will rewrite it. We'll have the inverse sine of 0.5582, which again, we figure out that it's going to give us an ambiguous answer. Remember, all students take calculus. We either can be over here or over here. And the two answers that we got, right, remember this angle, I'll call it theta, I'll call this theta prime. Theta was 33.93, theta prime was 146.07. Now we have to figure out which is the ambiguous case. This is the ambiguous case this time because if I notice my angle A up here is an obtuse angle. So this is the angle that I choose. So angle A is 146.07. And now I can do the same process to find angle B as we did in the last example. 180 minus 146.07 minus 23. That will give me that angle B is 10.93 degrees. And again, my law of sines, I can have 7 over the sine of 23 equals x over the sine of 10.93. Cross multiply. So I get x sine of 23 equals 7 sine of 10.93. I divide both sides by sine of 23. This whole thing you can plug in as one step in your calculator. Again, we can go over that in class, and it will give me that x is 3.40. I have now used the law of sines to be able to find all of the missing parts. Okay, this next example, I want you to try it in your notes. Let's call it example 3. Okay, solve for the missing parts of this triangle. I want you to do it on your own in your notes, and I will go over the answer in class tomorrow. We have A, 50, 30, 7, K, and M. Try it in your notes, and when you are done, that is all we have for today. I will see you in class.